The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. It is 12:59. We are 11 seconds early. Now we're just going to give people a few minutes here, not even a few seconds, to finish logging in, and then we will get started talking about what's new for milling 3D. Most of this I think I'm going to do via videos just to save on some time, because some of the stuff takes some calculation time, so we can fast forward through some of that. So without further ado, let's begin. So the first improvement has to do with constant Z finishing. For the constant Z finishing algorithm, we have, when we have a lot of bounding curves, calculation can be very long. So for example, on this part, there are, I want to say 600 bounding curves in here. Okay, and before I start the video, there's 600 bounding curves in here, and when you have that many bounding curves, the software, when it's cutting in sections, it has to check for intersections between every bounding curve. So that's what adds to calculation time. So the improvement in this case is in the cases where you have 75 or more bounding curves, you're going to get a new option up here in settings that basically allows you to turn off this automatic check for intersections in bounding curves. Okay, so what this video is showing you to start with is it's showing you, okay, the option doesn't exist yet because we have no bounding curves selected. And if we go in here and we select just a few bounding curves, for example, the option still won't exist because, for a few bounding curves, no big deal, calculation is just fine. So now if we cancel all of that, go back and look at this one, and then go back into geometry, we can show you that there is quite a few bounding curves. And a little hidden trick, if you want, you can right click and say show indexes, and it will tell you the index number of each one. So there's 600 bounding curves in this case. So when you have that many bounding curves, now in the general settings there, you have this new option called assume no curve imbrication. Now we could use the word intersection, but we wanted to increase everyone's vocabulary out there as well, so we're using the word imbrication instead. Okay, so imbrication is equal to intersection. And that's it. So by activating this, it just means we're not going to check when we're cutting the sections, and then the calculation time is significantly faster. Again, it's a very specific improvement for a very specific type of work, but now you know. Okay, from there, pardon me, I'm just going to pop out my questions. Just a reminder, if you have questions, feel free to pop them out there. The next improvement has to do with avoiding collisions with the shank body. So I'm going to go ahead and launch into that one. So in this sample, we have like a little electrode and something to understand between we're at 714 and prior. Let's get this thing up to where it brings the tool up. There we go. So in the previous versions of the solution, and let me bring this forward just a little bit more. When we are checking for collisions, we are checking collisions with this cutting diameter and this main shank diameter, but not automatically avoiding this cone or this second shank diameter. That wasn't supported yet. So now in 715, it is supported. So all we're basically doing is showing you in this video is showing you the way it was before. So you can see that the tool reaches only so far. Okay. And if we want to do this with the new version, we can go to collisions. And here you see the new option, discretization step for conical parts. Okay. It's an offset on the conical faces for the conical portions of the tool path or the tool holder itself. So then this takes some time to crunch out. So we'll fast forward that a little bit. And now once it's up to date and we go back and simulate or look at the tool, now you can see that the tool is getting closer in the areas it wasn't before. Okay, so we're really paying attention to the true profile of the tool as far as the multiple shank conditions that exist in tool paths now. Alrighty. Let's keep on going. So the next improvement we're going to speak about has to do with planar face machining. In 715, in the menu Planar Face Machining, in Settings page, we add a Collisions tab and 3 Tool Definition tab. Okay, so let's go ahead and take a look. So if we go to Collisions, now you can see in Planar Machining, we can take into consideration tool holder management. And like you saw in the roughing operation, it's taken into consideration even the conical faces at the back side of the tool. Okay, the other thing that is there as well now, zoom up and have a look. So now the planar faces is going as far as it can with the real tool shape. Okay, and if we turn all that off now and watch it again, now you're seeing that it's going to collide. Okay, so again, planar face machining, we're taking into consideration the multiple different steps you can have on the shank of a cutter now. Okay, this next one's kind of cool. This one allows us to divide tool paths by tool lengths. Okay, so in 715, for the roughing operation, we can now apply a divide tool path by tool lengths command. In the original operation, you must activate minimum the tool holder management, and if you want to activate machine head management, you can as well. So it is required to have tool holder management selected. So now you can see that it's doing everything it can to machine, and it's paying attention to the holder, and off you go. So there's your first result. From here, if we go to optimization, we're going to say divide tool path by tool lengths. Go ahead and activate it. And then in here, we want to go ahead and select what other tools we want to use. Now in my sample, I have these tools preloaded already, but you can see it's just the tool manager, so you can add them right now, or you could have added them ahead of time. And then the result of that calculation is like this. So you can see all the tools that have been used. Oh, sorry, you have your output distance there. If we look at this one, have that output distance and that tool shape, more importantly. You have that tool shape, that output distance. Okay, I think you get the idea of the output distances. And then you can look at each individual operation to see how it's been divided up based on which tool and which tool length is being used. Okay. Okay, next, we're going to look at an improvement on the XY bounding curve mode. In milling 3D operations, in the label, we show hide the XY limit for planes. Okay, so what do I mean? And this is a nice little improvement. So if we go here and we do roughing, for example, or we do finishing, doesn't matter. You have your toolpath preview, but you also have the ability to hide or show the bounding planes. Okay. So this way you can turn them off if they're in your way, or you can turn them on, whatever. Turn off your tool path, turn that on. Okay. And if we fast forward a little bit here, go to another operation. Again, you see the option exists there. Another improvement is also possible to fix only in Z, so no bounding in XY. You need to deactivate XY bounding. I don't know if we're getting to that yet in this video. There you go. XY bounding mode is outside, inside, or on. Okay. And then at the top there you see the XY bounding mode that you can turn on and off. Let's go back to this. There's your Z. Go. So now we're outside. And finally, if we turn off the XY bounding, now you notice that you only have access to the Z as far as the bounding is concerned. Okay, next improvement. This one is, again, similar. We talked about it in 2D a little bit. It's roughing number of axial passes. So instead of doing a depth of cut, you can just say, I want to machine this in 3 passes or 4 passes. So let's have a look. So if we go to roughing, of course, and we go to bounding, so we're going to select the area to machine, choose our bounding method. We're going to add this additional shape, why not? And then here, as opposed to doing an axial depth, so we have 2.5 millimeter depth of cut, we'll show that first. We're going to change to number of passes. Okay, so if we say we want 3 passes, the software is going to calculate automatically from the maximum altitude to the lowest altitude and just divide it by 3. Okay, so just like you saw in 2D milling, you have that option in 3D machining as well. Is there anything else that is important in this? Let's see. Nope, we're good. Okay. So constant Z, compensation with tangential and entry. Let's take a look at that one. So in constant Z, in the finishing algorithm for constant Z, it's possible to fix a plane compensation when entry and exit movements are tangential. So to do this, let's have a look. So we have plane compensation activated there. Okay, we're ordering by altitude. And we have tangential selected. If we switch to direct, you can see that it makes it so you cannot output plane compensation. We follow the same rules that are followed inside of normal compensation. So you need to have tangential selected. It's a requirement. Okay. And it can be, I take it back, it can be orthogonal as well. It can be a mix and match of both. Okay. That's that. Yes, that's plain 3D compensation. Okay, next sample here has to do with microparts. Okay. For people that machine really small things. So in Milling 3D, we can apply values on each parameter until 0.001 micrometers now. Okay, so we're going to take a look. If we go into here, you can see the operation. You can see the visualization tolerance is very small because it's a tiny part. I know it's not a very exciting part, but it's just to kind of set the understanding of this. So we're, 1 micrometer. For inch users, I want to say that's 5 or 6 decimal places out or something like that. Okay, and then from there, all it's showing is that you can work like you normally would work and create tool paths without it, taking forever to calculate. So if you notice the tolerance is really small. And the rest of this is just showing using small values on a tiny part with a small tool. Okay, so again, the possibility is there if you have to machine parts like this. I see a question pop up. Why is only one or the other 3D compensation type available sometimes? It is simply because it depends on the geometry, the entry, and the exit. Okay. Sometimes it depends on whether or not the machine supports it, even. So there's just rules that have to be followed. I'll try to find. I have a document somewhere that explains it. I'll try to find one and share it to y'all. Okay, so boost milling and roughing finishing. That's the next one. So let's take a look at that one. So in the milling roughing command, when we use the option roughing finishing, now we can use the boost milling algorithm as well. Okay, so the improvement is just that it is available when you're using roughing and finishing at the same time. And for those of you not familiar with roughing and finishing, it's a great feature if you have to rough and finish in the same operation with the same tool. Again, you can control the number of passes if you want, but you can see it does a nice job. Okay. I see a question there. How well is stock management update working with 3D Toolpath? If you're doing stock update for 3D Toolpath, use faceted stock. Using true solid stock update, you can try, but as we're doing real-time Boolean operations, if you have any type of tool with a radius on it, you might get errors in the stock update. If you use the faceted mode, it's relatively fast. It's like verify, in fact, and it works fine. Okay, last one I believe is boost milling and roughing with minimal material. So in 7.14 and before, with roughing, the minimal material left was not managed properly with boost milling. Now it is. Okay. So you can see we're just showing you where there's some material on the outside and how big it is. And now if we go to roughing, and we're going to come in here and we're just going to activate boost. Set a nice depth of cut. And then with the minimum material left, we'll leave it at 0.3 for now. And we'll have a look. And now you can see that it is finding the little bits of material it did not find in the past. Here we go. If we make that bigger, you should see that the areas of thin material on the outside are ignored now. Okay, so it's just an update to the algorithm to support the minimum material left when using boost milling. Cool. Okay, so that is the last topic for 3D. I believe this afternoon is 45D. So if there's no other questions, oh, wait, there's another question, hold on. Question for the end. Do you think there are more overall improvements to 715 compared to previous releases? Oh, that's a great question. I think there's more overall documented improvements for 715 compared to previous releases. I think it's a pretty healthy release. I think the last big release like this was 712 maybe. I will say 715 is a bigger release in general because not only are the number of improvements that we've added significant, but we also added, I think, 5 or 6 new product lines as well this year. So comparably, it is significant, yes. But many of these things have been under development for many years. It's just they're coming to market simultaneously, excuse me. Any other questions? So there's a question, is France still working on improving the built-in help? Yes. So every time that you guys report to us stuff that is missing or out of date, we report it to them. And typically it is being added and improved and is always an ongoing thing. These improvements come out in service packs. Okay. Any other questions? All right, cool. Then we'll see you guys at 3 o'clock for the next webinar. Until then, have a nice afternoon.